Hello, everyone. Today, I'm going to help answer the question, do we need Cilium to take advantage of Tetragon? And the answer for that is no. So what I wanted to do is actually take you through a lab environment where I've got Calico installed, but you can still see all of the powerful security observability and runtime enforcement capabilities of Tetragon without having to use Cilium as well. Cilium and Tetragon are open source projects that have both been donated to the CNCF by Isovalent. And now I'm going to take you through some of those really cool capabilities of Tetragon. As a quick overview, please make your way over to the tetragon.cilium.io docs page. And essentially, Tetragon is going to enable you to detect and react to security events such as process executions, system call activity, I/O activity, looking at network and file level access. Well, we're actually going to look at some of those examples today in this lab environment. So I'm going to go across into my lab environment. I'm using what actually is hosts our labs itself for Instructs, but you could run this on your local machine as well to get started and figure out how things work before maybe you use this in your production environments as well. So I'm just going to use Kind, which is Kubernetes in Docker. Really simple configuration. So I'm just going to show you that configuration now. And I've already pre-built the cluster in the background as well. So essentially, we've got one control plane node, and then we've got a couple of worker nodes as well. We've disabled the default CNI from being installed by Kind, and in the background, I've actually installed Calico as an open source component as well. So let's go kubectl get node. See that all my nodes are healthy, and then also as well, I can check the status of the Calico deployment as well as at CNI level by looking at that daemon set, and we can see that that's successfully rolled out as well. So the first thing that I'm going to do is I'm going to start by installing Tetragon into my environment. So we're going to do that by adding the Cilium Helm chart repo by using that force update command on there as well. It'll make sure that we get the latest information from that chart. Now we're going to install Tetragon. So again, we're going to reference that from our repository. We're going to reference the chart of Tetragon. And we're going to install it into the kube system namespace. So we can now see that was pretty quick. And we're just going to wait for that rollout of those daemon sets to be completed. Okay, so next, I want to install a demo application that we can use to actually capture some process events for and manipulate that information and what's going on at a kernel level inside of that demo application as well. So in today's demo, we're actually going to cover things like looking at network observability, so getting information from the TCP level. We're going to look at system calls, so writing file access, and we're also going to block the ability to write files as well later on. So first, I'm going to create a namespace called demo app. And then I'm actually going to deploy one of the Cilium demo applications. Well, if you've ever used our Isovalent hands-on labs, then you're probably quite familiar with some of these demo applications as well. Okay, so we can see here we've deployed a service called Death Star. We've got a deployment of Death Star, which is going to create some pods of that. And then we've got some two individual pods, TIE Fighter and the X-Wing pod as well. If I just get all in there, we can see that everything's been created and running as well, which is fantastic. So I'm just going to clear this down to make my terminal look a lot neater. So the next step that I'm going to go through is I'm actually going to install the Tetra CLI. So this is a CLI tool that allows us to look and manipulate the events that we pull from the system as well. So I'm just going to curl from this location here to download the Linux AMD 64 binary of Tetra, and then I'm going to install that into my user local bin area. However, if you go to the Tetragon docs and go to the install CLI tab here on the left-hand side, you'll see that you've got a quick install for each of your preferred environments inside of your guest operating system. Okay, so I would recommend running, if you're going to follow along with this lab, actually use maybe 2 terminal windows as well, because one thing that we want to do is tail the logs from Tetragon itself, whilst we also then run commands in a separate terminal window to our container. So I'm going to click on terminal 2 here, and I'm going to run this command. So what we're actually doing here is we're getting the logs using kubectl from the Tetragon pods, and we're looking for the container, which is called export std out, and we're looking to follow that. We then are piping that into our Tetra CLI using the get events command. So basically, we're telling it that events are there. And at the moment, we're looking at this using the compact view as well. And what I'm actually doing here is I'm telling it to look for the namespaces of demo app and my particular pod of X-Wing as well. So because we're using the kubectl logs command, it means that we're able to pull through the Kubernetes metadata there as well. And the Tetra CLI is able to pass through that Kubernetes metadata, meaning we're able to use things like namespace and pod names as well, which makes life a lot easier when you're trying to troubleshoot or trying to dive into various security events as well. So I'm just going to leave that to run. We can see that nothing's happening right this second. And next, what I'm going to do is accept into my demo app of the X-Wing pod. So if I go back to terminal 2 now, straight away we can see that you could see that I've hit the SH as running process inside X-Wing pod. And if I run who am I, we're going to run an ls. We'll run a cat on its own, and this isn't going to return things. We've not given it a file, so I'm actually just going to exit out that with Control C. And then this time as well, we're going to do cat with the file we're interested in, which is the product UUID to read that. And then I'm just going to exit out of here. So let's go back to terminal 2. And now we can see a number of those processes and then the exit of those processes as well. So this is just by installing Tetragon on its own with no additional configuration. And for example, here with the cat command where it was waiting for further information, we can see that I actually send signal to that to exit out of it, and we've captured that signal as well. Whereas here, these are the result signal returns from the application itself because it's done what it needed to as part of that process. Okay, so I am going to exit out of that. So one of the other areas that I can show you this happening. So at the moment, we'll look at this nice compact view, which is giving us nice little symbols and coloring of information. But actually, this is backed by a full log, which you could pass using a JSON viewer. So in this example, I'm going to use JQ. So again, what I'm doing here is I'm getting the exact same file that I talked about earlier that we did in the previous command. But rather than pipe this to the Tetra command, we're just going to use JQ, and we're just going to select any process execution. So that's going to be the array of that information, where the pod name is X-Wing, or we're also looking at process exits as well. So I'm just going to SH into here. And if we go back to the terminal, we can now see I've got a whole host of information of what's going on inside of my container as well. So again, we can see that Kubernetes details. So we can actually even see things like the container IDs that are being running on the node itself, the ID of the images that are being used. So we've got that full name there with the SHA, and we've also got that more human readable name as well. We can see things like pod labels being brought from our Kubernetes message, which is going to be important later on as well. And then we can see the binary that was being run and any arguments that are attached to that as well, and also where in the environment that this is running. So we can see it's running on my worker node 3. Okay, so let's clear that down. And I'm just going to exit out of here. I'm going to clear that down as well. So next, what we're going to do is I'm going to apply one of our example policies for Tetragon, which allows us to see TCP events going on inside the environment. So we're going to do this quickly in the background here. We can see that I'm getting this from the Tetragon repository in GitHub in the examples, and I'm going to show you that now as well. So we have in the public repo an open source level, a number of available tracing policies as examples as well. Now, these may feel a little bit daunting when you go through them. I know there's a task to add some more information. Here's a README file to explain what some of these do as well, but don't worry, I'm going to take you through some of these in particular. So the first one that we're interested in is the Connect setup. So I'm going to go back to my lab environment here. And let's look at this in a YAML format itself. So, of course, we've got the tracing policy, which is the the custom resource definition that we've applied this to, that's set up by Tetragon when we install it inside of our environment. We then got our specifications. So we're using something called kprobes, which is a kernel level probes. This is at a Linux level itself. And then essentially under that kprobe, we're telling it what it is that we're actually looking for itself. So we're looking for the call of a TCP connect at kernel level. So we're looking for that kernel level detailed TCP connect. We're looking for any particular arguments as well. So here we're looking for an argument that happens at the start. We're looking for the type, which is socket, because we're looking for network level information here. We don't need to tell it what the max data is or the return copy, but these are for more advanced use cases where we need to take that information from that argument and maybe use it elsewhere inside the policy as well. We're also looking for the TCP close call, and we're also looking for a TCP send message call as well. And you'll see here, for example, that the close is also a type of socket, but the send message is a type of int going forward as well. And this will allow us to capture TCP level information inside of our environment. So next, I'm going to go back to my terminal, and we're going to go back to that same command that I used before, exporting those logs to the Tetra CLI. And then if I go to my first terminal, so we're going to do kubectl exec in the namespace of demo app. We're going to make that interactive. We're going to do Xwing as my pod, and I'm going to curl. And let's just go to the Isovalent website at the moment. Okay, so we can see obviously we've nothing returned there in that, because typically that's going to be redirected to HTTPS. However, let's see what's happened inside of our logs. So now we can see that process command. So that was the actual command that had been executed, but we've also now got what happens at a network level as well. So we can see here that we've got the connection. We've resolved that IP address, the DNS name to this public IP address. We've then got the actual send message, which was 77 bytes, which was basically give me your information. And then we've got the closing of that as well at the end of that curl message. And then we've got that stateful exit as well. Okay, so let's just exit out there and clean up my terminals again. So next, one of the most powerful things that I think from a security perspective is the ability to be able to see the process capabilities of commands that are run inside of containers, and also the kernel namespace access that they have as well. Now, to get this additional information, we're going to need to make a slight modification to the installation of Tetragon. So we're going to use the Helm upgrade command. We're going to set the Tetragon value for enable process cred to true, and enable process namespace to true as well in the Tetragon namespace. Now, at the moment, because we installed this with the default values, we're basically, these are the first level of values that we changed, so we don't need to do anything else here. So I'm just going to run this command. That then basically updates the config map in the background, and we'll look at that later on as well as we get into a little bit more detail. But one of the things that we will need to do is we need to restart that daemon set for Tetragon as well. So we're going to restart that using the rollout restart command, and then I've just run a second command there to watch the status of this as well to make sure Tetragon is updated. Okay, so I'm actually going to deploy a new type of pod into my demo environment as well. And the reason for this is because we're going to look at the privileges set. So what I'm first going to do is I'm going to actually start watching for this pod before it's created. essentially, again, we're following these logs, so we're waiting for these pods to come up. And let's take a look at that pod itself. So we're going to apply this manifest here. And the most important bit here is we're going to set this pod to run as root. So we're giving it the security context privilege equals true. So we're going to give it privileged access inside of our Kubernetes environment that we're running. So I'm going to go back to terminal 1. We'll clear that down just so it looks a little bit nicer. So we're going to do kubectl apply in the namespace of demo app to file, and then we're going to do this to my interpreter, and we'll apply there. We can see that being created. And now if I go back to terminal 2, we can see the full processor of that container comes up from scratch as well, which is fantastic. But we've also got some additional information here, so we can see that Linux kernel capability that's applied to each of the commands that run there, which is the cat system admin. And this is one of the takeaways for you to do today as well, is to go back and start to, maybe if you don't understand the different Linux capabilities, is have a little bit at some of the man pages for Linux capabilities and start to dive into that as well. And you'll start to see why this level of security information is really important inside of your environment. Okay, so I'm going to clear that down again, and we'll clear this down. So the next area that I wanted to cover is the ability to set policies at a Kubernetes and a pod selector filter. So that gives us the ability, because we've installed Tetragon into a Kubernetes environment, it's aware of Kubernetes, but we also need to make sure that configuration is in place. So we're going to run another Helm command. This Helm command sets the policy filter configurations true, which essentially then tells it to be able to filter on that Kubernetes data that's being brought in. I'm also using the reuse values here as well, because I didn't want to lose that previous configuration that I put in place as well. So what I'm going to do here is I'm going to run the rollout again to restart that daemon set. Whilst we wait for that in the background, though, I'm actually going to get the config map for Tetragon to see those configurations in place. So what is it I'm actually changing when I'm using Helm? And the answer here is I'm actually changing this configuration map. We can see there we've got the policy filter enabled as true. I've also got the process credentials and namespace enabled as true from those earlier commands. You could just go in and change this configuration map itself if you wanted, but typically it's easy to manage these types of things using Helm instead. Okay, so let's see where we're up to with the state of the daemon, the restart of the daemon set. And that's successfully rolled out. So that's fantastic. So now what I'm going to do is I'm actually going to install a new namespace policy in place. And actually what I'm doing here is, go back to my Tetragon examples, is I've taken the Tetragon example of file name monitoring filtered. And if I have a quick look at that, you see that it's a kind of tracing policy looking for calls against security file permissions, security mmap, and also, where is the other one? Any path truncates, which allows us to see any reads or writes against particular files. And here we've got the value of the etc. password file that in particular we're interested in. However, there's going to be a little bit of a difference in the example I'm going to show you now. So I'm going to drag across my visual code window. Let's make that a little bit bigger for you as well. So I've actually taken that policy and I've edited it slightly. So we're going to actually tell this to be a tracing policy namespace. And actually this command up here also needs to be applied at a namespace level. So this will now need to be applied at that demo app namespace I've been created and working with. If I didn't apply that, it gets applied to the default namespace. This policy is only going to be applied to resources within the namespace it's applied to. We do need to, again, as mentioned, change to the trace policy namespace as the kind. The rest of the information here is pretty much the same, but I've also extended the values as well to look at the shadow file, which is where other security related password information is going to be. And that's it. So I'm going to take all of this command, we'll move that to the left again as well. And I'm going to apply this in my terminal window. and that creates that policy against my environment. So if I do a clear now, so I could do a kubectl get tracing policy. And tracing policy, you can see here, there is no namespace information. These are applied at a cluster wide. If I do tracing policy namespace, again, nothing's found at default namespace, but if I do a hyphen for all, A for all namespaces, we can see here that it's applied at the demo level. So now I'm going to go back into my terminal window and I'm going to get the Tetra events. I've removed the pod name off. I'm just going to do it against the demo app for the time being here. And then again, what I want to do at this level is I want to exit into my X-Wing pod. And I want to run commands such as bin echo, let's do Cilium rocks, and we're going to put that against my password file, if I spell it correctly there. Also, let's do this a different way. So let's use tools to interactively edit this file as well. So go see that Cilium rocks has been added there. I'm going to do insert mode. I'm just going to do something here. And I'm also going to right click and save that file. Now, if we go back to this terminal window, we can now see that those processes have been picked up. So we can see the process that was run. We can see the commands and the arguments with that. We can see that it's writing against those files and then exit again. And the same if we use by here as well as echo. So I'm just going to exit out of here and we'll clear that down. And I'm going to exit. I'm just going to break that line there and I'm going to clear this down as well. The last example that I wanted to show you was the ability to create a namespace policy against a pod label as well. So of course I've been using two pods in here. I've got my test pod and I've also got my X-Wing pod that allow me to do things. So again, if I just bring back my window here, we can see again, I'm going to trace a tracing policy namespace again. Again, it's going to the demo app namespace when I apply this. But here in the spec level, I've now added the pod selector arguments and I'm matching any label with the label of test. So at the moment, none of my pods have that label, but we're going to add that in. We're then going to use a slightly different example, which basically is going to deny us writing access into the temp file location. And essentially here, we're going to follow anything which is the prefix of temp as the directory. And then we're looking for a couple of different system calls. So again, we explain these different system calls that you can hook into in our Tetragon documentation as well. So I'm going to copy all of that. But also what I'm going to do is I'm going to show you where in the Tetragon documentation you get that information. So if I go back to this overview, and if I go back to tracing policy here as a concept, you can understand how a tracing policy works. You can learn via an example and also explain in more detail about hook points. So these are where we actually are getting the information from and the arguments that we're interested in, because this happened at kernel level, and also the selectors. So the selector is how do we filter on those events that we've collected based on the hook point, but also do we want to action any of those events as well. Go back to my terminal window, I'm going to paste that in. And the last bit I want to show you here is this action at the bottom there, which is sig kill. And that basically is going to say, if you see anything writing a system call, which is writing to that location, then kill it straight away as well. So now we need to label my pod. So I'm going to create against my test pod. I'm going to add the app test there, which matches the pod selector, which is up here. And now if I sh into that pod, and if I go back to this terminal window and I'm going to look at all namespace events again, we're going to create a new file inside of the temp location, because that's where we're interested in. So we're going to use the touch command for that. And now if I try and edit this file, so I'm going to do edit, and I'm going to do Tetragon will stop this, and I'm going to exit and do right and quit. And now we can see straight away that that process was killed, which means that the file was not wrote to. So if I do cat temp new file, we can see that there is no data in there whatsoever because that information wasn't wrote. If I exit out of here now and I do a clear on there again, we'll just recreate that the same with the X-Wing. And again, I'm going to do the same thing here, which allows me to touch that file. I'm now going to edit this, do the insert, Tetragon doesn't care about this pod. And I write and quit, it saves it. And now if I cat that file, if I spell it right for the file name, we can see there we've got my data inside of there. I exit out of this, and that's it. That was a very quick overview of using Tetragon. And we start off with the question, can we use Tetragon without Cilium? And the answer is completely yes. But also probably what you've noticed here is I didn't actually touch on Calico whatsoever outside of at the start showing you Calico was installed, because with Tetragon we can get security event information. We can even observe the network level of what's going on as well without needing Cilium, because we're still using those same eBPF magic in the background to get all of that data as well. Hopefully you've seen how powerful Tetragon can be. To answer your question of, well, that was really cool, where do I get started next? What I would recommend personally is if you go to our Isovalent website, go to our labs page, got a couple of ways to explore Cilium, but I think the one that everyone's going to be interested in here is this security professionals link. And we've got a number of curated hands-on labs that are completely free for you to go through and understand Cilium and Tetragon in more detail, and even look at the Isovalent Enterprise for Cilium offerings. So with the getting started for Tetragon, you're going to look at some of the information I already showed you. We're going to look at actually attacking a pod and getting a foothold inside of there. So we're going to become the attackers as part of this lab as well. And then you're going to see how we capture all that information as well. So how would you actually figure out that you as an attacker are in that environment? And I actually think that was really cool. It's one of my favorite labs that I went through. From an enterprise level, so what extra, how do we extend Tetragon further at an enterprise level? We can do things like TLS visibility. So TLS gives us encryption in transit, which is fantastic, but how do we actually ensure what's going on inside of that data? What happens if someone bad encrypts their data when they're inside of our environment? And then finally, as well, we've got the security visibility. So we're going to bring that process data and network event data together as well. So how do we see things like late process execution? So what happens, we've got all that information from a pod when it's running at the start, but what happens towards the end? How do we view that through some of our other observability tooling, such as Hubble Enterprise? And then how do we bring that data back in as a JSON so that we could use it for our other SIEM solutions as well? Hope it's been really useful. Thank you very much, everyone. Bye now.